All right, so in 7.5, we talked about tangent. If you haven't already, pause the video to allow everybody to work on this warm-up for a couple of minutes and then resume when everybody's ready, and I'll go over the answers, and then we'll do the notes for 7.5 or 7.6. So for all of these, we're going to use that tangent of an angle is equal to the side opposite it over the side adjacent to it. So number 1 says if A is 18, so I'm going to label this diagram, if A is 18, B is 80, and C is 82, find the tangent of B and tangent of A, and then write each answer as a fraction and a decimal rounded to 4 places. So let's start with B. I would say that the tangent of B is equal to the angle opposite, or the side opposite B, so B is here. Opposite would be 80, over adjacent, which would be 18. And then I would reduce that, so they're both divisible by 2. That would be 40 over 9. And then I'll use the calculator, 40 divided by 9, to get 4.4 repeated. So because we're going to go 4 decimal places, it would be 4.444. So this would be B. Then tangent of A is going to be the side opposite A. So A is over here. Opposite would be 18. And adjacent would be 80. And I get 9 over 40. And then divide 9 by 40. And I get, this one terminates 0.225. So if this was on the part of your test without a calculator, you would leave it as your ratio. And then if you had the calculator, you would take it to the next step. Number 2 says if A is 17 and the measure of angle A is 31 degrees, find B to the nearest tenth. So we're still using tangent, but this time we have the angle. So the tangent of the angle, 31 degrees, would equal the side opposite it, which is 17, over the side adjacent to it, which is B. B is in the denominator, so I'm going to multiply both sides by B. And it cancels from here. And then I'm going to divide both sides by the tangent of 31. And it cancels from here. So B is equal to 17 divided by the tangent of 31. And I get B is 28.29. And this says round to the nearest tenth. So we're going to make that 28.3. Another thing to remember here is the shortcut is that if the number's in the numerator, you can just take that number and divide it by what's on the other side. Okay, number 3 says if A is 9, angle B is 74 degrees, find B to the nearest tenth. So now I say the tangent of 74 is equal to side opposite it, which is B, over side adjacent, which is 9. This time the number's in the bottom, so I just multiply on both sides, and then I'm going to type 9 times the tangent of 74 into the calculator. And I get B equals 31.38, and it says round to the nearest tenth. So we're going to do 31.4. And number 4 says A is 5 and angle B is 79 degrees. Find the number of square units in the area of triangle ABC to the nearest tenth. So in order to do area, I need to do 1/2 base times height. I know the height is 5. But I need to find the base, which in this case would be B. So I'm going to use tangent first. I'm going to say the tangent of 79 would equal opposite, which is B, over adjacent, which is 5. Multiply both sides by 5. B equals the tangent of 79 times 5. which is 25.7. Now I can find the area by doing 1/2 25.7 times the height, which is 5. So in the calculator, I can either multiply those two and then divide by 2, or I can do 0.5 times 25.7 times 5. And I get the area of this triangle is 64.25, which is going to round to 64.3 units squared. Okay, now we're going to talk about Chapter 7, Section 6, which is sine and cosine ratios. So in 7.5, we talked about tangent, and in 7.6, we're going to add to it sine and cosine. Sine and cosine, which will be abbreviated as SIN and COS on your calculator. This says let triangle ABC be a right triangle with acute angle A. The sine of A and the cosine of A are written as follows. The sine of A is the leg opposite that angle over the hypotenuse of that triangle. And the cosine of A is the adjacent side over the hypotenuse. So in the diagram that's here, if I'm looking at A, angle A is up here. The sine would be opposite, which is A, over hypotenuse, which the hypotenuse of that triangle is always going to be C. Cosine of A would be adjacent, which is B, and hypotenuse, which is C. And then sine of B, opposite B is B, hypotenuse is C. Cosine of B, adjacent to B is A, hypotenuse is still C. So now, if you look at this word, and it is pronounced SOHCAHTOA, it's probably the most important acronym you'll learn in math. And it stands, so it's spelled SOHCAHTOA, and it stands for the three trig functions we've now talked about. S for sine equals opposite over hypotenuse, that's your O and your H. So SOH. C for cosine equals adjacent over hypotenuse. And TOA for tangent equals opposite over adjacent. So that combines what we learned in the last section and in this section with the sine and the cosine. All right, example 1 says express A, sine of A, cosine of A, and tangent of A. And then B, sine of B, cosine of B, and tangent of B as a fraction. So I'm going to start with the sine of angle A. A is up here at the top. Sine, remember SOHCAHTOA, SOHCAHTOA. Sine is opposite over hypotenuse. So the right angle should be here in this bottom corner, which makes 5 the hypotenuse always. Opposite A would be 3. So this would be 3 over 5. Cosine of A would be adjacent to, now remember both the 5 and the 4 are adjacent to A, but 5 is the hypotenuse, so we use 4, and the hypotenuse is 5. And then the tangent of A, which is opposite over adjacent, 3 over 4. Now I'm going to answer all the same, but for B. So now we're looking at angle B. The sine of B, opposite B is 4. Hypotenuse is still 5. Cosine of B, adjacent to B is 3. Hypotenuse is still 5. And tangent of B, opposite is 4. Adjacent is 3. If these fractions were able to be simplified, we would make sure we simplify them, but none of these are, so we're going to leave them as they are. Okay, example 2 says use a calculator to find. So now we want to just make sure that our calculator, we locate that sine button. Remember that there are two different types of calculators. One where if you hit the button that says sine, the word sine appears. And in that case, you're going to do sine of 30 in that order. So sine of 30 should give you 0.5. Other type of calculator, when you hit sine, it actually tries to find the sine of what's already there. The name itself does not appear. So if you are going to if you have that kind of calculator, you're going to first type 30 and then you're going to hit the sine button. Either way, you should get 0.5. So then the cosine of 42 would be 0.7314. We're going to round to 2 decimal, actually we're going to do 4 decimal places so we're consistent with the rest of this. 4 decimal places. So cosine of 42 is 0.7431. Now C and D are different because this time it doesn't have the angle. So you're saying sine of what angle would be 0.145. And for these, we use the buttons over the sine, the cosine, and the tangent buttons that you see on your calculator. So to get there, you're going to hit second, and then you're going to hit sine, and you should see the sign to the -1 above it, and then type 0.1045. Second, sine 0.1045, and you should get 5 point, we're going to keep 4 decimal places here, 9983. Actually, it's 99836, so we're going to do 9984. And again, if you have the second type of calculator, you're going to do 0.1045 first, then you're going to do second, then you're going to do sine to get the sine -1. And the last one, again, we don't know the angle. We're saying cosine of what angle is 0.9659. So we're going to do second cosine this time to get to the cosine -1, 0.9659. And I get 15.0057. So if you're given the angle and you want the trig function, you're hitting the normal sine, cosine, tangent buttons. If you're given the trig function and you're looking for the angle, that's when you're going to use the -1 buttons. Okay, example 3 says, find the values of x and y to the nearest integer. So we are solving this right triangle like we did in the warm-up, except we're going to use different trig functions. I'm always going to start with the angle I'm given, the side I'm given, and then one of the variables. So let's say I want to solve for x. 28 is in this corner. 1,000 is the hypotenuse of this triangle. And if I want to solve x, and respect to 28, x is opposite. So I look back to my SOHCAHTOA, and I pick the trig function based on the information I have. So I'm using opposite and hypotenuse, which tells me to use sine. So the sine of 28 degrees is equal to the opposite side, which is x, over the hypotenuse, which is 1,000. And then I'm going to multiply both sides by 1,000. And in my calculator, I'm going to do 1,000 times the sine of 28. And x is equal to 469.4. And this says to the nearest integer. So I'm going to look at my tenth. It's below 0.5. So I'm going to say that this is closest to 469. Now I'm going to solve for y. So I'm going to stick with the information they originally gave me. I now know x, so I can use the Pythagorean theorem, which is a good way to check it. But because I'm unsure if I'm 100% sure that I got x right and I've rounded x, It is safer to stick with the information that you're originally given, which is the angle and the 1,000. This time, in respect to the 28, 1,000 is still the hypotenuse, but y is the adjacent side. So hypotenuse and adjacent tells me I'm going to use cosine. I'm going to say the cosine of 28 degrees equals adjacent, which is y, over hypotenuse, which is 1,000. I'm going to multiply by 1,000 on either side of the equal sign. And I do 1,000 times the cosine of 28. And I get y equals 882.9, which we're going to round to 883. So now, because I have a calculator, it'd be nice and quick to check this using the Pythagorean theorem. I can say that 469 squared plus 883 squared should equal 1,000 squared. Now, probably not exactly because we've rounded these, but it should be kind of close. So this is 219,961 plus 779,689, and that would equal 1,000 squared, which is 6 zeros, or 1,000,000. So 219,961 plus 779,689, and I get 999,650. So I know it's not exact because I rounded them to the nearest integer, but I know it's at least close to my answer and I'm on the right track. Okay, find x to the correct nearest, x correct to the nearest degree. So this is like the ones we used in the calculator a couple examples ago, where I'm looking for the angle. I have the two sides. In respect to that x, 18 is opposite, 30 is the hypotenuse. So remember the SOHCAHTOA part of that would be the opposite and hypotenuse. So we're saying sine of the angle that we don't know is equal to 18 over 30. Because we're looking for the angle, we're going to say sine -1 of 18 divided by 30. You don't need to reduce it because your calculator can do that work. And that gives me that x, the angle x, is 36.8 degrees, which, because we're saying nearest degree, is going to be 37 degrees. And example 5 says, find the measure of the three angles, round to the nearest tenth. So what's tricky about this one is that this is not a right triangle. So I can't use SOHCAHTOA on it until I make it a right triangle. So we're going to make this isosceles triangle, because this is congruent to this. We're going to make this isosceles triangle into two congruent right triangles. When we draw the altitude to the base of isosceles triangle, we divide it into half, so it's 2 and 2. So now I've got one triangle on this side. This is 2, and this is 5, and I've got the same on the other side. So it doesn't matter which one I use. I want to find both this angle on the bottom and this angle on the top. So let's call this x and this y. So I'm going to use the inverse. I'm going to use the -1, sine -1, cosine -1, tangent -1, based on the information I've got. In respect to the x, 2 is adjacent, 5 is hypotenuse, which means cosine. Cosine of x is equal to 2 over 5. And I do cosine -1, 2 divided by 5. And I get x equals 66.4 degrees. It says to round to the nearest tenth. So this is going to be this angle, 66.4. Because this is isosceles, it's also going to be angle C. So now you have two options. Easiest is take those two and subtract them from 180. Because 1, 2, 3 angles should all add up to 180. and I get angle A at the top is 47.2 degrees. So angle A, 47.2 degrees, angle B, 66.4 degrees, and angle C, 66.4 degrees. The other way you could have done it is find y here, which is going to be half of this, and then double it. If I had done that, 2 would be opposite. 5 still the hypotenuse, so that would be sine. Sine of y would equal 2/5, and I would do sine -1 of 2/5, and I get 23.6 degrees. That's 1/2 of that top angle. So double it, and I get 47.2 degrees. So either way you approach this, and whichever way makes the most sense to you is how you want to do it, you get the same answers for all 3 angles. That wraps up the notes for 7-6. So make sure you submit the warm-up and the notes together in one file. To today's assignment on Canvas, and then you can use the rest of the time to work on your 7.6 homework assignment. Have a great day.